All right, folks. What we're going to hack away at now is looking at some command line arguments and some C string scenarios and pushing C string into C++ strings to make them a little more manageable. Um, in order to do that, I think the first thing that you need to notice is that when you see a char star, you're probably looking at a C string, but you might also just be looking at a pointer to a character, which could also mean that you're looking at a character array. It turns out that C strings are handled as character arrays. Um, and so if you have a string like hello, then that's really just a character array with the characters HELLO in it. One thing that's special though is that the very last character in that array is a null character, which you can represent by \0. And the null character is just kind of a string terminating character so that the system knows that when it reaches that it's at the end. And this allows a language like C++ to store strings in a way such that it only costs them 1 byte. They don't have to store the size explicitly. Although in C++, when you move up to using the string class itself, it will be storing the size explicitly. And so it does take a little more room in that aspect. And honestly, using C strings versus using a string is probably not the way to go. But the system kind of deals with it at a lower level still, and so you can see some of that appearing. We're going to use strings in this particular program, and we're also going to use IOStream to do our prints. We could use printf, but if you're starting to use C++ strings, then using IOStream probably makes sense. But it's weird because you're kind of intermingling this old C style with this new C++ style, and you just kind of get used to that when you're dealing with more systems programming type stuff. Okay, so what you see here is a main int main, but inside the parens are two new parameters that don't have to be there, but are sometimes there. The first is an integer. You can name it whatever you want, but argc is kind of the traditional name for it. Argc stands for what is the argument count? What is the number of arguments that were used to call this program? And then you'll see this kind of strange setup here, which is there's a char star, which means we're talking about C strings. It's an argv, which is kind of like the vector of arguments. And then there are these brackets. So this is really a two-dimensional array. The first dimension is kind of each argument, and the second dimension is that you have a list of strings. So the way you handle that is you know how many arguments are there from argc, and then you can kind of enumerate or walk through these to deal with them as you like. What I'm doing in this program is I'm making a variable for an address. You'll notice that I didn't use this using namespace standard that you sometimes see in intro programming C++ stuffs. Instead, I'm going to explicitly label any class that I use with whatever namespace it's attached to. So I have to add this standard namespace in front of string. If you want to do using namespace, that's fine. But as you move into production level, you'll see that less and less. So we're going to be pretty explicit and just say, hey, this is a standard string and not any other kind of string that you may have heard of. And this might help you kind of keep in mind that we're not dealing with C strings, or that these are different beasts or entities or classes or objects that perhaps aren't standard in the sense that they're standard, but they're not standard in the sense that they're not um, kind of that core C functionality that's deep embedded. It is core C++. It's not a big deal. So we're making this my address variable, and I'm just calling it localhost. And what I would like to do is allow the user the option to change those through these arguments and then demo that for you. I'm outputting how many arguments there were just so that you can see that. And if the number of arguments is even, okay, that's what this mod2 equals 0 does, then I quit the program. Okay, so let me show you that in action first real quick. So I'm gonna close this. I'm gonna compile it real quick. G++ HWCPP. There it is. I'm gonna run it. And what you'll see is the number of arguments is 1, and there's a cout at the end of the program that I didn't show you. If I make the number of arguments be 2, which is ./HW34, then the program quits immediately after this, right? And now you might say, but there's only one argument. It turns out that the executable itself counts as one of the arguments to the exec that's used to call this program. So this has two arguments, HW./HW and 34, and this one has only one argument. Okay, so let's dump back into our code real quick. If the number of arguments is 3, then what I'm going to do here is I'm going to grab the C string that is from the second argument, which is really the first argument to your program. And then I'm going to grab a C string from the last argument. Since there's 3, you have 0, 1, and 2. 0 is the name of the executable, how the executable is called. and then one's going to be that first thing after the executable, and two's going to be the second thing. I turn them into C strings here just by assigning them to string variables. So I have an opt string, which is that first one, and I have an arg string, which is that second one. And then what I'm doing is I'm walking through the first one, the optional string, the option string, and I'm checking to see if any of the characters is the letter C. Now, there are some other ways to do this, but I explicitly did this with a for loop on purpose to kind of get you back into this habit of doing things. So I'm walking through this string, I'm looking for the character C. If I find it, then I'm changing this variable up here, my address, to be equal to whatever this third, the second argument or the third entry into the command line was. And then at the very, very end, after I get out of all of these if statements and for loops, I output that. So what this says is, if I have a C in my second argument, then I'll change my third argument to whatever the third thing is. Okay. So when I execute this, if I execute it like this, I've got a Y and then something. This says my address is localhost still. But if I change this Y to say whack, let's say, then suddenly it's going to change that local host variable to whatever the third argument is. And so this is a way to signify options. So I can signify that this variable is supposed to change as long as there is a C here. It could be minus C, it could just be C, or it could be part of something bigger. Pawman doesn't work, but Pac-Man will. And the idea is that you might have other variables that you eventually want to set. Now, this isn't going to change my localhost variable because my command explicitly says if arg c equals 3, but you can imagine like setting two different things. Like maybe you're setting an IP address here, and then maybe you set a port here, and it might look like this in some way or another. So if I delete the port part, this will actually work with the way the program is written. Okay, so this is a brief walkthrough of C strings, strings, how you might walk through a string, how you might convert a C string into a string. You can convert a C++ string back into a C string um, by calling on its .c_str function, which sounds a lot crazier maybe than it really should. But oh no, homework CPP changed on disk. Let's reopen it. There we go. Sounds a lot crazier than maybe it should, but we could do like a standard cout output my address .c_str, and that c_str will give you a C string associated with this my address object, because under the hood these things are all ultimately C strings. So you can see that this process works the same, and this is outputting the C string that's associated with this string object that we created from this C string object when it was passed to the command line. All right, command lines are really fun. Adding options to your programs in this way are really fun. It's a great way to be able to test out new features and things like that. And your clients are going to need it. So this all applies to your latest homework. So get ready for that. All right, thanks everybody. Take care of each other and take care of yourselves. Bye.